Hello everyone. Today we're going to discuss a brief introduction to React. React, the basic idiom, how it works, what the idea is behind it, and how to do state management. Can we fast the script? Hello everyone. In this video we're going to discuss an introduction to React. We're going to start with the basic way React works, and then we're going to move on to state management in React, which is slightly more advanced than just a basic markup. And we'll discuss some of the patterns that arise when trying to apply software engineering code reusability and abstraction principles to React. And we'll move finally up into the domain of the so-called widget library that we use heavily at Hoppinger to standardize and simplify. Now, I don't know if simplify is the right term, but certainly to standardize the way we write React, and also to create a sort of funnel of success that forces, in a very rigid and type-safe idiomatic way, the principles of referential transparency, purity, etc., that ultimately result in better state management. It might be a bit of a heavy path, so I'll do my best to keep it nice and interesting. What we have here is a very simple React application. It has been created with the framework React Create App, which is very handy because then you get an application and it works right out of the box. We have here the app Lambda, which is called, has no parameters, and simply returns a bit of markup. Let's put a friendly message, hello React world, exclamation mark. Let's go to the application in Chrome, and there you go, we have hello React world. What's happening in order to get this apparently reductively simple message on the screen is quite intriguing and is quite a lot of work. We pass this app object, this app function actually, to the render method of React DOM, which put it in strict mode, doesn't really matter, and will take an element with ID root and put whatever comes out of React inside this element. So take notice, we have root here. Let's go take a look at the structure of the page. We have the elements, the head, and in the head, let's go down, in the body, sorry. And here we have the div with ID root, and inside it we have a div class app with the text hello React world. So this div ID root is a sort of static bit of the is meant as a static bit of our page, which we give to React as the empty canvas where React is going to put the result of all of its operations and all of its rendering. And React is ultimately going to produce a series of elements, a series of nested elements dynamically. Is going to store those elements, and then 60 frames per second it will take the elements it has produced and put them in the browser, put them here under the root element, but it's also going to merge whatever elements it has with the new elements it has just produced. So it's going to constantly see, okay, this is what I would like to have, and this is what's already there, and instead of throwing what's there away and putting the new ones in place, it's going to do this dynamic merge. Now, if let's say we were to change something here, so notice that we have a div with class name app, and I've put more exclamation marks, and we go now to Chrome. Now we here see the exclamation marks. We have automated loading, but reloading, but otherwise we could simply reload manually. And you can see that we have the div class app hello React world. Oh, I'm going to scroll a bit. Oh no, I cannot. No. There we go. Hello React world exclamation marks. So there we are. Okay. Nothing particularly exciting yet. We can change the structure of what we have here. So for example, let's add a button. Let's add a button that says click me. Let's make it attractive. And in on click, we ignore the event handler and we put a message box. You clicked me. Again, not very exciting. Now we have the text, hello React world. Notice that this element has been refreshed, so we see it differently because it's and it's closed, so we have to reopen it. We have the div class app, we have the text, and we have the button. And when we click the button, bam, you clicked me. Okay, that's not particularly exciting, but that's exactly what we expected. It's interesting thus to notice that when we write here what looks a lot like normal HTML and JavaScript, it actually isn't. So these here are placeholders. This is not a div, just as this is not a button. These are placeholders with which we tell React, I want a div and I want a button inside the div. And then React is later going to turn this into the actual elements, and the elements in the resulting HTML, it looks a lot like this, which is nice because it means that there is no cognitive overhead of us having to translate, okay, what is this? Yeah, obviously it's a div, so it's nice, but it's just a syntactic illusion that this is a div, and it's a syntactic illusion that this is a button. These are objects in memory that React is going to store, and later on is going to create corresponding elements in the web page. Okay, now, so this is simple, but not very exciting, because there is no state whatsoever, and we know that an interesting application has to manage some state. Let's therefore define a simple state. We want to be able to input a person, and a person will have a name, a surname, and an age. Notice that we can here apply all the very complicated typing discipline that TypeScript allows, but not right now. Maybe later. I don't know where this presentation is going to end up. Our goal is therefore to be able to input a person inside our application. Whenever we can get away with it, it's highly recommended in React that our components are stateless, like app. App is stateless, it doesn't have state. But sometimes we really need state. If we need to save the person somewhere, well, we need at least a root component at the top of the application, or as high up in the application call tree that actually is able to contain state. And we can turn this function into a class that extends, inherits React.component, and component is intrinsically stateful. The component wants two things: properties, which I'm going to leave as an empty object, and a state, which I'm going to put down as a person. The component needs a constructor. In the constructor, we get as input. So if you look at the component and you see that we have two parameters, P and S, I'm going to ignore SS. P stands for properties, which is read-only information that is given to the component as a sort of computational context, but the component may not change the properties. And a state. And the state is ownership of the component, and the component may change its state. So here we get the properties, and well, the type of the properties is simply the empty record. We have a context, which is something internal to React, which we absolutely never should use. And what we have to do is we have to set up the state, and we get a state variable because we're inheriting from component, and component already has the state attribute, and the state is a read-only person. We can't really change it. More about that in a second. We put in an initial value, name, surname are empty, and age, I'm going to start at 18. And then the component must have a render method that returns a JSX.element. And a JSX.element is precisely one of these structures. I'm going to put it in the annotation just to be verbose. We have to return one of these HTML-looking structures. But JSX.element is again this object. So JSX.element is not an element, it's an object in memory, just a normal object. I need, I think there's a way to create this by, I don't know, there's something like JSX.div or a constructor like this, instead of creating it with this pretty syntax, but obviously there is no reason whatsoever not to use the pretty syntax, unless we're trying to achieve something relevant. Okay. Now here we can start putting inputs. The first input is going to get as value, because an input has an input and an output. So the component gets a value, and this value literally is the input of the input component from the data flow perspective of the application. The value is this.state.name in this case, and then the input is going to raise the onChange event. It's going to raise the onChange event whenever we type something into the component, and onChange gets the first thing that has been typed. So literally it's this.state.name plus the character that has just been typed, and the input simply tells us, okay, this is the new value I have. What do we do with it? And what do we do with it? Well, now we have to put it in this.state.name, because the input is not going to save the value automatically for us. It's just going to tell us, hey, here's a new value, do whatever you want with it. And if we don't put the value in this.state.name, then this input component is not going to change. So when we change, we can't, for example, say this.state.name is equal to e.currentTarget.value, because, well, the state is read-only. And as much as I guess we could do something obscenely evil like this, but no, absolutely not. Why? Because we have to tell React, hey, the state of this component has changed. Because when React sees that either the properties or the state of the component change, it triggers a re-render of the component that's going to re-inject this.state.name in the input component. Otherwise, if we manage to get away with doing this, which I'm not even going to try because I have no idea what happens, this would probably not force React to re-trigger and to re-render, because this is not telling React the state has changed. In order to tell React that the state has changed, we can use a function that React offers us out of the box, which is this.setState. And setState is meant to accept either a new person, which I'm going to put, which I'm going to put here, this.state, where name is e.currentTarget.value. And by doing this, we say, okay, this is the new state I'd like this component to have. And this is not putting the new state inside the component right away. It's simply saying, okay, this is the new state I'd like to have. The syntax you might know, so the curly brackets create a new object or record. The three dots with a record make a shallow copy of all the fields of this .state. So be careful, because if state also contains some fields which point to other objects, those objects are just referenced. So it's not a copy of the objects, it's literally a reference to the same object. But then we say, take everything in this .state, but name is going to be different, so name is going to be overwritten with e.currentTarget.value. Let's see what happens. Now we have a text box, and if I start typing Giuseppe Maggiore, then there you go. Well, sorry, just Giuseppe, because this is the name. There you go. Then we get our updated state. Notice what happens if I were to remove onChange. Now I can type, but nothing's happening. So we really need onChange, and we really need the this.setState. And you could argue that a huge amount, I'm going to pull a number a bit out of my nether regions, 80% of the complexity of a transactional React application has to do with the management of state. So it doesn't have anything to do with all of these pretty HTML elements, renderers, etc. Most of it is state management. So this is crucial. That's the reason why we're already here 13 minutes into the video. Okay, all right. So now we can copy this and create the editable surname, and also make the age editable. And now it's complaining, but that's no problem, because the value has to be as a number, and the type here is number. Oops, it's a string number, the flag number. And now we have our three values. And notice that these things are updating. Why? Because the set state is forcing a re-render of the component. And now I can put Giuseppe Maggiore. But, well, okay, we guess that the state is being updated, but we can't really see it. So now I'm going to also put console.log here and say the component is being re-rendered with new state, this.state. Now you see that, oh, the component has been rendered twice already, with a new state, which is the initial state, which is empty string, empty name, empty surname, and age is 18. I'm going to write my name, and you can see that set state is happening with one letter. Actually, it's been re-rendered twice, because React has the total freedom of deciding when and how it renders itself. So you can see some duplication, but you can also see that the state is actually being stored in the component, which is very nice, which is exactly what we would expect. Okay, now let's say that when we press the save button, which I'm going to create now, we also want to save our the input we've put now by simulating a call to the network. Now, I don't really need in this case to perform an actual call to the network, rather because also if I were to simulate a call to the network with a server that runs on my local host, I would be fooling myself into thinking that my application is significantly more reliable than it actually is. So let's simulate the scenario of someone driving on the street, for example, and someone driving on a street and having a very flaky connection. Let's create promise, a local promise that accepts our person and tries to and pretends to try to save it in a situation where the connection is very unreliable, and also where it takes quite a long time to complete a saving event, because when you're developing, if you use something local, then typically, well, locally your machine is pretty fast actually, and it doesn't take a long time for the browser to communicate to a server that's running on localhost. So you're never going to see how long it really takes to download data, to send it back, especially under heavy load or with a bad connection. And you might be tempted to think, oh, my application is fast enough that it doesn't even need to have a proper animation for loading, or it doesn't need to properly convey the fact that you're loading. But so we really have to be careful to learn to simulate real-life conditions when working in practice. So without further ado, let's say save person is a function that takes as input. You know what? I always kind of like to have. Do I have fun here? I think I do. We have a function abstraction. So save person is a function that takes as input person and gives us back a promise of unit, because we don't really need, well, we don't really need to get any data. Okay, and we take as input a person to save, and we return a promise, a new promise actually. Why is it unhappy? Oh, because I forgot the closing bracket. Yes, so we return a new promise, and the promise is created by calling either the resolve or the reject callbacks. So a new promise, if inside the body of the promise we think that we're properly done, then we call resolve with, in this case, an empty value, or otherwise we can call reject and we can give it a reason why we ended up rejecting. So we could say, okay, in any case, we're going to pretend it takes some time. So we're going to wait. We're going to wait, and then after we've waited for, let's say, math.random between 0 and 1 times 500 plus 5 plus 250. So this is a call that's going to complete in 250 milliseconds plus a random number between 0 and 500 extra milliseconds. Let me be sure this is milliseconds. Yes, it is milliseconds, ms. And after we're done, well, we throw another random number and we say that if the random number is greater than 0.9, so it's a number between 0 and 1, so in 90% of the cases, we actually want to fail. And we say bad connection. Well, let's put in a sad face. Otherwise, we resolve. This is a promise that is mostly going to fail, and it's also going to take its own sweet time at failing. Before we proceed with making the actual call to the promise, let us refactor our state a little bit in order to reflect the fact that we are going to have a call to a promise, and therefore that our state must contain not only the person has the proper data, but also some extra information that conveys the fact that we are performing some concurrent operations next to it. So without further ado, let's define our app state as the data of type person, and at the same time also a status. Even merge them together, actually, there's no need to be so fancy, which is saving. We have multiple ways of modeling this. So for example, we could say that our status is saving or saved or nothing. Or in this case, I'm going to keep things simple, and I'm going to say that the status might be saving. Now I'm going to say that our app extends React component with app state instead of just directly the person, and obviously now things start breaking down. The data now contains name, surname, and age. The input value name comes from obviously the data, and well, the last bit, the right bit, the set state, I'm going to fix in a moment, because now I have to say that the data inside the state is the same this.state.data. I know this is quite ugly as a matter of fact, but well, more on this later on. Now let's copy and paste this bit here. Yes. Now, because what we're trying to rebuild here is a full state, which contains all the fields of the state copied. So for example, the status, but if later on we're going to have more fields, they are also going to be included in the first shallow copy. And then we state that the data is the same as this.state.data, where the surname comes from the value of the current target. And we do the same for the age as well. Now we're almost ready to go. So what we can do as the first step towards proper synchronous state management is that we can say that when we click the save button, we run save person, and we pass save person this.state.data. Let me check if everything looks in order. Oh, I do see a mistake here. We want this promise to be very faulty, so this condition is going to be true in 10% of the cases. So let's turn it around. Now this condition is going to be true in 90% of the cases, so we will mostly get errors. And if we were to run this, oh, it's unhappy. Oh, it's broken. Let's see. Let's find out. No, nothing. Okay. So as we type, we get the same state management, but now you can see that we have split the state and the data inside the state, because the state might contain a lot more information than just the data being filled. You need information about which promises are running or validation, etc. And now when we press save, now we have no idea what happens. Oh no, look, we are not catching promises. But that's what is happening. We have no idea, the user has no idea and no feedback, and now we're going to extend our application to process some feedback for the user. So without further ado, so what we want to do now is, before we start saving the person, we want to signal in our own state that the status is saving, that we are saving, that we are performing some operation. Set state has a very handy second parameter. You can say to set state, okay, here's the new state. Oh, sorry, dots. And the new state now contains the status, which now becomes saving, which is good. But the second parameter is a callback with which we can say, okay, right after the state has properly been set, because we don't want to call to start the promise, which is a background process, so it might take quite some time. We want to be sure that first we have the proper status, which is saving. So this callback here forces the sequence of first the state, this new state becomes the proper active state that we want to have as the new state, and when that is done, then save person may actually start saving. So when while saving, we could say that disabled is this dot state dot status is not saving. Actually, we might even not need the saved status. Okay, so there you go. That's 1, that's 2, and that's 3. Let's try this. Let's go to Chrome. Let's type in. Oh no! Now they are all. Disabled. No, there is something wrong. It's disabled if obviously. Sorry, it is obviously disabled if the status is saving. Otherwise, it stays enabled. Let's try again. Now they are enabled. Yes. Now I'm typing, and you can see that the component is updating. Now I press save, and they are disabled. Okay, that's nice. And now they stay disabled, which to an extent is actually even it's arguably even better because it's showing the brokenness of the application slightly better. Let's also put something else. Let's put here some ugly message that if the status is saving, then I actually even want to put here the string is saving. You can very clearly see that I do not have a feel for design and visuals, so the application is getting uglier as we speak. Okay, Giuseppe Maggiore 34 save. Now it says saving, but now we also see that the promise has been caught. Sorry, that the promise is done with an error. All right. But also suppose that the promise were succeeding. So let's say that the promise always were to succeed. Then also in that case, so now I'm making the promise succeed every single time. GM save, now it's saving, and oh, still bad connection. Yes, because it should be end false. Now it's always going to resolve. Save, saving. Now it's resolved, but still everything is remaining locked. But I mean, and also I can still save. I can save multiple times while the component is saving, so I could keep pressing on save. So let's switch the disabledness of the button. I don't know if React is smart enough to really disable it. So, and it's disabled if the status is not. No, if the status is saving again, because we don't want the user to be able to do anything but wait until we're done saving. So we're making the application more and more robust. So now it says saving, so that's nice, and we can't really do anything, which is good, which is very good. But now obviously we have to re-enable the application when it's safe to do so. One might say, okay, then, so when the promise is successfully done, we can set the state again. Set state. And the state is this dot state where the status is undefined because the application can only be saving. That's good. But we might also want to catch, and catch is called when we have an error. And now the application is, fortunately, React is not going to complain anymore that we're not catching our exceptions. And let's go to status undefined, even though, well, that's not really ideal, but more on that in a moment. We could at least show a message. Let's show an alert that says. We can show an alert that says the saving operation could not be completed. Let's make the promise unreliable again. And now if we go here and Giuseppe Maggiore 34, we save. Saving. Oh, the saving operation could not be completed, but then we get control again, and we can try again. We can try again. We can try again. And we can. Oh, and now it succeeded. Yes, congratulations. We're happy. Okay, so our application now is a bit robust. And now let's take a look at how much state-related things, state management-related things do we have. So that's what I meant when I said really most of a modern transactional web application has to do with just the management of state and little else. Notice how much state management is happening, and not only that, but also some particularly complex sort of state management, because to be honest, if I look at these nested callbacks, some people even call this callback hell. You know, it's just, I mean, yeah, okay, they are not functional programmers typically, because for functional programmers this is just we just call this Tuesday usually. But yeah, I mean, there's a lot of stuff that's happening, and there's a lot of pretty advanced-ish constructs of computer science that are needed here. So we need to understand, for example, that this here is indeed a continuation or a callback, and it's only going to be executed after set state is done by setting its own thing, and this is all asynchronous. So you have no guarantee about when this is going to actually happen. And you also don't know when and if this is going to happen at all. So you have to make your code very robust, and your code must be able to include a proper response for all the different paths that might happen, and not only the paths but also the possible delays that your application might encounter, depending on how long it takes for a promise or a callback to be done, or for the user to click on something, etc. So we have all these things that might or might not happen, might or might not fail, might take longer than you expect, and so on. But at least now we have a decent application. Now, before we continue though, I'd like to at least address one not so minor point that we haven't addressed yet, and this is well, quite unideal, because all these things are happening in a concurrent way. We don't want to set the state right away to whatever the state is right now with some extra information. Rather, React makes it possible for us to provide here a function that will update the state whenever possible. So instead of depending on, oh wait a second, it's complaining. Oh yes, I put the bracket in the wrong place. So instead of saying, okay, this is the new state, we give an updater function that takes as input the state at the last possible second. So set state, so it doesn't know. So this function doesn't know what the current state is. The state is going to be passed by React itself at the last possible second. So when this set state occurs, this update function is saved as is, and later on it's going to be called and it's going to be invoked with S becoming the latest state. Then you don't run the risk of your update being somehow outdated or incomplete. This is a much safer pattern. Let's see. Oh, too many commas. Yes, he's right. Let's try again. Because when dealing with a lot of concurrency, your application becomes less and less predictable, and one way of removing this predictability is to rely on updaters and updater functions and chains of lambdas, rather than relying on direct concrete values. That's slightly safer. Okay, but so at least now our application is indeed, oh no, I forgot it here. So all of these set states, I mean the difference is not that big. Also syntactically, instead of using this .state directly, you simply give such an updater function. There's a lot of brackets involved, but again, at least our application is now pretty solid and quite reliable. So this is code that is starting to look like, at least in broader structure, as code that we might almost want to, well, almost there, run in production. So before we continue, this code here, this is, for lack of a better word, ugly. Why is it ugly? Well, because the bit I find the ugliest is this, because it's kind of obvious, and it's kind of also implied by the fact that we have, this is not a fault of the language, by the way, but it's just a fact of life. When you have to do a nested update of an object inside an object, you end up having these things. Oh, I just noticed I missed an error. That's terrible. Yes. And you also notice how easy it is to make mistakes, like I just did when doing all these manual updates of state. Fortunately, we have a library, which is TS Lenses, which Hoppinger developed. And this library makes it possible to simply define nested setters. There is also another construct, which is the entity, and I'm going to show how this works. So suppose we have an entity, and this entity is in our case our app state, and we want to make a modification to this entity. Now this is not really a modification, so I use the term a bit loosely here. I want to create a new entity which contains the same as S with some exceptions which are also nested. So I can say, okay, let's start by creating an entity around this dot state. Then I can set stuff. I could say set, let's say the status to, and then it gives us the previous value. I could say no, I don't care about the previous value, and put it to saving. And the result, I can commit, because this is just a callback, so again an updater function, and when I say commit, it's actually going to get give us the result. And the result here is again an app state where the status has been set to the string saving. Okay, that's close enough to what we want, but there's another function which is set in, which is quite handy, because now we can say set in data, and inside data now I get the person, and on the person I can do, for example, a set of the name to something else, like John. Oh, wait a second. Oh, no, obviously this is an updater, but I ignore the previous value, and then I can commit. And the handiest of this is that now what I get from the result is the very same object, but inside the data we have the new value for name. And I could define this as a function from app state to app state by getting the state as an input here. So this is getting to look very much like what we have here, but there's less brackets, curly brackets, and especially this kind of repetition here, which is very annoying, is simply contextually implied, because P here takes over the role of representing the context of the fact that we're now inside the data. Okay, that's good. So now I should actually be able to simply say, hey, you know what, you are going to take as the name the current target dot value, and look at all the curly brackets disappearing, which, well, to me at least, it's something that well, makes me quite happy, as a matter of fact. And if we try to run this application now, it's kind of working, but oh, there's lots of warnings. Now it is working because the state is being correctly saved, but now it's complaining because React now pretends that this E thingy here is the event handler that's coming out of JavaScript, out of, let's say, the browser with all the data about what's happened when you clicked. That's actually not true. And if you look at the error message carefully, it says synthetic event, so it's talking about the E object, is reused for performance reasons. And if you're seeing this, you're accessing the method current target on a released nullified synthetic event. Why? Because when we call e.currentTarget.value, we do it, inside the updater lambda of the state. So we were solving a potential problem when it comes to concurrency and closures, but we've introduced another problem because this updater uses e.currentTarget.value after the onChange event is done. So the onChange event is done, set state gets its updater, but does not call it yet. It just keeps it close to its heart, and later on React is going to call this updater. And when the updater is called, it tries to read e.currentTarget.value, and bam, then we get an error or a warning from React. So there is an ugly solution for this, but it is at least a proper solution. We could say const value is e.currentTarget.value. So now we're this really is an ugly solution, but now at least what I'm doing here is I'm saying, okay, you know what, first we're still inside onChange, so that's safe yet. I store e.currentTarget.value, I stored it inside the value variable, and now value simply copies whatever string came out. Then I create this updater function with the value, and this value doesn't depend on E, or neither on E nor on e.currentTarget, so this is safe. And then when the updater is called, it simply refers the value, but the value is safe. Okay, it's doable, but kind of ugly. Perhaps a better way would be to define a series of updaters. So for example, we could say that set name is a function from app state to app state. But this function, before taking the app state, or well, let's see what we want. Yes, before taking the state, it takes as input the string of the new name. So new name into yes, and here we get a new name. Why is it unhappy? Let's see. Oh, this looks very broken. What's wrong with p here? Parameter p implicitly has an any type. Why? No, that is not true. This is exactly the same code as we had before. Oh, we're missing brackets. Okay, what's it complaining about? Let's find out. Type entity set field is not assignable to type app state. Now let's find out. Well, let's see if a type annotation helps a little bit, even though this surprises me to no end. Now it knows that S is an app state. Let me see what it understands. Okay, if we were to say set here, okay, it knows that the key is either data or status, so that is positive. And for set in, the same. And for set in, only have data or status, okay. And the data here, it takes as input a function from entity person into the new entity, yes. So here we should be able to do the set. Okay, this is quite puzzling. Then we ignore the previous value. We take the new name, which again the system knows it's a string, and then we commit. Oh, I forgot to take the commit with me. Oh, how silly. Okay, now, and what I can do now, I could say, okay, set state, and set state it just wants a function like this. So from app state to app state, and so I can call set name. Just pass it e.currentTarget dot value, and then I don't need to do any commit. Now look at that. Look at the fact that the code is starting to also look a bit prettier, because I'm isolating away bits of I'm isolating away some irrelevant well, some irrelevant, some separate bits of state management, because the logic of how you set the name into the app state, or well, we could even go for a better name here. So set app state data name, for example, or just set data name, whatever. I mean, but now we're kind of isolating the fact that we have the state, we have a bunch of functions to update the state, and then we simply use these functions in a way that is compatible with React. Now we could have set data surname, and obviously I know what I'm going to put this new value here, because I want to be able to copy it in multiple places. Here set is type safe, and that's the surname. I'm going to also rename this to new value, and then we have the set data age takes as input a number. Notice that we have type safety here, which again is very nice, and when I put here the age, then now it's accepting the new value as a proper parameter for that. And now I can call set state simply with the proper setter, set data surname, and everything should just work. Oops, no, too many set states. Set data age value as number. Let's run this and let's see what happens to our big scary warnings. Oh, nothing whatsoever actually. Why did the warnings disappear? That's interesting. The warnings disappeared because when we call set data age, we evaluated this parameter. So this creates a new value, which we call in this case new value, and this new value is stored in the closure of this second lambda, effectively removing the dependency on the event handler. The irony here, and I do really like it, is that by using a proper software engineering approach of abstracting things away, and by just introducing a function with this parameter here, we're turning this value here, which we can't use, so this is kind of a hot potato. We can't hold on to this value. We have to drop it as quickly as possible, but by just passing it to set data surname, and we just extract the string, we make use of it, and the string is literally saved in the closure of new value, which is literally a variable, which we can't see because the closure, we can't see it explicitly as a variable, but it is a variable in memory. And this removes the ugly warning. So software engineering well, has more powerful positive effects than you might imagine. Okay, so now as a quick recap, what we've done in this application is we've defined a way to input and manage the data from a person, and not only to manage it, but also to manage it in a concurrent remote way by invoking a promise with the saved that simulates the saving of this data to an unreliable remote connection, a remote server. Our state management has been neatly separated, so the logic of the state management has been neatly separated from the logic of the application. Now, not fully, just for the form a bit, but we should do it for the other set states as well. So they should say now start saving, and they should say stop saving, for example. Actually, you know what? Let's do it, and then we can call it a day. So start saving. And in this case, well, this doesn't even need any context, so this is just a function from app state to app state. We don't need a new value anymore, and this is just a shallow setter, so set saving, oh sorry, status. IntelliSense is always nice. Then we ignore the value, and here we put saving. It's slightly unhappy. Why? Oh, because it's so this library is actually allowed to change. It's allowed to change the type of variables. So now I'm going to say that it's changing the status into saving, and now it's happy because now I'm really saying no. This is not just a string. This is this flag. I think there's another way of convincing TypeScript that I'm producing this with the right type, so not as a string, by casting it as saving. Because this is at the same time, according to TypeScript, both a string, which is in the more general understanding, but I can also say no, you're not just a string, you're the saving string, which is a separate type, which matches the type of the status. Otherwise, we get a compiler error that says that I'm producing an app state where the status is a string, but it's not a string. It's supposed to be either saving or undefined, and in this case, now I'm forcing it to go into saving or undefined. Okay, so here I can say, instead of, and look at all these things. I mean, an arrow is always kind of pretty and it looks very hardcore, but it's nicer to simply say, start saving, which is nice. And here we can simply put, well, stop saving or done saving. Obviously we don't have it yet, so I'm going to add it in a moment, and that's the same. And you could even argue that all of these things might even go to a separate file, which is certainly a good idea. Now our code looks pretty. Let's see if it also works, or if we have to do one last minute of debugging before calling it a day. Saving, the operation could not be completed. Now we save again, now completed, save again, uncompleted. It's quite boring, but at least it's the application is telling us all we need to know as users to know that things are working. Oh, results, we're done, we're happy, and the application sort of works. Okay, so that's good. Obviously, we are still missing plenty of stuff. Well, the application looks ugly. Later on, we're going to play around with the Office UI Fabric framework from Microsoft that, well, makes things look a little bit more professional, even though, well, not that much less ugly than now, at least. Then we're going to also try to make the application slightly better by ensuring that when the saving operation could not be completed because of a network error, we'd like to automatically restart to at least try multiple times without having the user have to do the retry manually, which is nice, which is user friendlier. And we'll streamline our state management because indeed, well, this whole thing is pretty complex to write, and it's pretty error prone. You might forget all of these things, and notice how, and really notice how if I delete stuff, well, the compiler just doesn't care. Or the compiler does not have enough information to be able to tell me that now I have a horribly botched application, meaning that, well, this code is dangerous. It's a dangerous design pattern because it can go wrong, and it will go wrong many times. So that's going to be the focus of the next part of this presentation. Thanks a lot for your attention so far, because I know this is a lot of information to process. Now, before we continue to the final bit of the presentation, just one last minor detail. So obviously, as we've built the application now, every single bit of functionality is simply here in the render function. We could have moved the state away, so we are neatly abstracting and modularizing our application. Everything is in the same file, but just for the purpose of this presentation, obviously, but you could imagine that the interface person, for example, could be moved together here with the state, and this block here could move into a separate file. This is API stuff, so it's in the API layer of the application. So we could neatly move these things away, but the question remains, how do we split stuff with respect to the main application? Because you could imagine that now this is simple, but you could have multiple steps in a form. You could have something that is far more complicated than just one single form with a bunch of fields. It could be subforms or multiple fields that you want to somehow group together, and you don't want to end up with an application with a single big state and a single big render function. Also, because especially these two bits are exactly the same, minus, I think, a tiny difference. The tiny difference being what input comes in and what update function do we run when dealing with this bit of with this specific kind of input. This one is not exactly the same because the type is different, but you could imagine that you're going to have a lot of numbered inputs in your application, and moreover, this also looks a lot like these two. But for the moment, let's give us as the final task on this piece of code to try to abstract away these two identical bits of code. One technique I personally really like is to define a generalized version of code. So const, I'm going to give it a random name, and we know that the thing that's renderable has type jsx.element, and I create my function, and it's going to be my string input, and I put both versions of the code under each other, and then I start aligning the things that are the same. I mean, obviously your mileage may vary in this, but then I like to parameterize because, okay, so, but then this way it's clear what's the same and what's not the same. So we have the first instance of something being almost the same, and clearly we need to parameterize this bit here. We could have a boolean here, which is disabled, slightly more general, but I really want to, I don't want to overgeneralize this. So we could say that the status is either saving or undefined. Yeah, I mean, why not? And here we therefore just have the status, and there you go. Then this goes away. Then we have the two values, and well, they are strings. I'm going to call it the data. Yes, just data. And here the data becomes a string, and this other bit can go away. And finally, and this is where it gets slightly more interesting, because now we have a parameter which is an operation. What happens when we get an onChange? We don't want to overgeneralize again by saying that this is something that gets an E, and the E is a React change event HTML input element. Do we really want to have a string input function that gets that as input? Obviously not, because that says way too much about how the string input is implemented, and it says very little about what's actually happening that's semantically of value for the function we're building. But what really needs to happen is how do we update the state? That's all we need to pass with respect to a string. Or we could even say, okay, you know what? There is a string into a string goes into void. Let's go for this one. So on new data, then we have, oh no, wait a second, I have the function, so fun string into void. Is it happy? Yeah, because the TypeScript does treat void as a proper type. Okay, cool. So here, what I can do is I can simply call on new data. Notice that the code we get as a result is cleaner. There's less stuff going on. So if you compare this with the original code that we started from, it was everything was happening in there. So we have obviously disabled, value non-changed. That's related to the aspects of input that we're using actively. Then there's the status. The status is saving or not, and it comes from this.state. Then there's the name, but the name doesn't come from the state. It comes from data inside the state, and so on. This is very intense, actually. This is simpler. This is less intense. And the nice bit is that now I can call our string input function, which you could imagine being just an HTML element. As a matter of fact, I simply give it, look, the code stays roughly the same. I have here the new data, v, and then I can simply call this.setState of setDataName, because here at this point I know that this string input is going to put the new value v into the name of the state, and off we go. Oh, and we're missing a bracket. Okay. And this is less intense than this. I mean, cognitively speaking, 1, 2, 3, and then 4, 5, 6 things are happening, whereas here we have 1, 2, 3, 4, 5, 6, 7, 8, plus I think 8-ish, 8, 9. So this is good. And also here the string input is kind of just conceptually saying okay, give me a status to determine whether or not I'm disabled or enabled. Give me the value I have to say to show in the input, and tell me what to do when I have a new value of the input to save it. And that's it. And it's abstracting the logic of the data management. The logic of the data management from the the HTML structure to which that data management gets mapped. And also, well, this also fits horizontally because it's literally less code. So we actually get to do a sort of one-liner, which is nice. Which is this is significantly less code. And here we have a set data surname, and pum, a lot of stuff disappears as well. It's also possible to use the string input as just an HTML, a sort of HTML looking tag. So we could take these things as we could take all of these things as input. So we could say in a big object. So let me see if I remember what this looks like, because the syntax of this is with the decomposition syntax, if I'm not mistaken. Let's see. I think this is the right way to go. It's a bit exciting. I so don't remember what this looks like. Okay, now, no problem. What I'm going to say now, oh yeah, no, sure. I mean, I'm looking up the data. Let me give it another go. It's a bit embarrassing, but well, I'm going to be honest, I'm not going to edit this. So if I make mistakes, you are going to see them. Okay, so this is the type. This is a type, so this is good. And this here, yes, finally. So what I'm doing is simply stating that this is the type of the record I'm passing, and instead of saying that what I pass is just a full record like input, and then I could do input.status, input.date, etc. I decompose the record right away, and I give a name to each field. So if you take a look at data, well, data is a string, the status is saving or undefined, and non-new data is the function. But now, well, obviously I can't call it like this anymore, but what I can do, which is nice, is that I can here put, for example, the status as this.status, the data, as this.state.data.name, and React recognizes this record object as something it can accept in the HTML element format. And now it's unhappy. Why are you unhappy? Now, okay, again, so we have the properties, and these are passed as separate properties. The error is complaining. Oh, now, first of all, this is not a good way of having this comment. So let's let React deal with it. And then property string input doesn't exist. Oh, wait a second, let me try something stupid. Oh, okay. So, very important thing not to forget. A custom element has to have a capitalized name. Okay. Good to know. I had forgotten about this completely. And we can also put its little brother here, and obviously its little brother is now in function call mode, which by the way is still valid. So remember when I said in the beginning that these elements are no more and no less than just functions or functions or objects. Functions or objects that we simply instantiate. Well, that's the case. That's the example. These are the two ways for invoking this component. It wants the last curly bracket, and these two syntaxes, by the way, are exactly the same. And it's important for you to realize, I guess, that React's pretty HTML-like syntax is nothing special. It's not really magic. Sometimes it's great and it works and it does what you want, but it's just syntactic sugar. The truth of the matter is that you have a piece of code that is going to produce somehow a JSX.element, and React needs a way to access this JSX.element to go on about its own rendering cycle. Obviously, this is prettier, especially if you come a little bit from a web development background, but this is absolutely okay. Now, let me finish aligning to the pretty version. And there we go. Something about this specific pattern. The string input is built the proper way. Proper in what sense? Proper because any React component must be stateless unless we're talking about the parent component at the top of the application. Any other component should never be stateless, barring a very, very, very limited series of exceptions that you might consider to not really even exist. But let's assume, for the sake of the rhetorics of this discussion, that there might at some point be an exception, but we're most likely never going to encounter it. So please check with your supervisor if you think you found one of these exceptions, because that's most likely not the case. Components must be stateless, meaning that they get as input what they have to their current context, and they don't change it internally. They simply give it back to us via a callback when they are done processing or they've got an input from the user, etc. So components never have state besides the top component at the root of the application. So you could imagine that app being, in this case, the root component of the application is entitled to have a state. All the other components only have properties. And sometimes the properties are pretty complicated stuff, like a callback. But let's see what this callback does. So on new data, what does it do? It just calls set state, but it doesn't call set state on the full state, because it wouldn't make sense to give the string input visibility of the full state. The string input doesn't really care about what the global state looks like, so we give it set state but reduced, because this is a sort of smaller version of set state. You could even imagine it's kind of set state but narrowed down to only change the name inside the data of the state, meaning that when we call the string input, we know for a fact that this string input here may only process the name and has no physical access to set state and to the global state. The only thing it can do is it can change the data name. This also means that we can much more quickly find out what's happening to state, because most of debugging, guess what, has to do with finding out how and when the state did not contain the data we wanted, or got to the point where some state transition, so we went from one state to another, and that's not what we were expecting or looking for.